In this question, we're asked to combine several skills that you may have encountered in previous questions to find the empirical formula and name some ionic compounds with oxyanions. So let's go ahead and get right to it. So here we have Mg2 plus and we have phosphate. PO4 3- is the most common oxyanion of phosphorus and it's called phosphate. Always the most common is called 8, has the suffix 8. So we have Mg2 plus and PO4 3-. We do what we normally do. Mg2 plus, PO4 3-, cross the charges, and we get Mg3 parentheses because it's a polyatomic ion, PO4 2. So this is the empirical formula of the compound that is formed. We now need to name this. To name it, we need to go back to our diagram here, flowchart, that shows us how to name it. So first, does the compound contain a metal? Yes, it contains magnesium, and it does. So it does contain a metal. So yes, it's ionic. Is the metal capable of forming multiple charges? And then it says generally this is the transition metals and the metals under the nonmetals on the periodic table. Well, magnesium is in period 2. It's a main group element, so it's not a transition metal or a metal under a nonmetal. Said another way, it's not capable of forming multiple charges, so therefore no. Name the metal, then name the nonmetal ending in "ide" or the polyatomic anion. In this case, we have a polyatomic anion. We have phosphate. So this is called magnesium phosphate. All right, the next one. We have cobalt 3+ and NO2-. Same thing. CO3+, NO2-. Remember, NO2- is a nitrogen, 2 oxygens, and a negative charge, not a nitrogen, 1 oxygen, and a 2- charge. That would be different, so it matters whether the numbers are subscripted or superscripted. Cross them. And because we need multiple NO2s, we have to put it in parentheses, CO, parentheses, NO2, bring the 3 down. So we get CONO2, 3. So going back to our flow chart, it's definitely a metal, but this time cobalt is a metal capable of forming multiple charges. It's a transition metal. So this time on this area of the flowchart, we select yes. Name the metal, then name the nonmetal ending in "ide" or the polyatomic anion. Use a Roman numeral to indicate the charge on the metal. So here, to name this one, we need to use a Roman numeral. So, since cobalt is 3+, this is cobalt, Roman numeral 3. The 3 tells us the +3 charge on the metal. Always the Roman numeral tells us the charge on the metal. And now we need to name this oxyanion. Well, for the nitrogen oxyanion, it's NO3-. That's called nitrate. Remember, the most common one always has the suffix 8. In this case, we have one less oxygen. It's NO2. One less oxygen has the suffix "ite." So this is cobalt 3 nitrite instead of nitrate. So we just literally are only changing one letter, but that letter is very important. Next one, we have copper interacting with this bromine compound. So we have Cu+, BrO3-. Since they're both +1 -1, it's just Cu BrO3. And in this case, you do not need parentheses because we don't need multiple of this bromine polyatomic ion. So now we need to name it. Again, we could use our flowchart again, but in order to do that, we need to determine whether or not copper is capable of forming multiple charges. And when we look, copper is right here on the periodic table. It is a transition metal, which is capable of forming multiple charges. So again, we do need to use a Roman numeral to indicate the charge on the metal. So this is copper 1 for the +1 charge. And then the bromine oxyanion that's most common is BrO3-. So this is copper 1 bromate, because this is the most common one, so we end in the suffix ate. Last but not least, we have barium and the chlorine containing oxyanion. So we have Ba2 plus ClO4 minus. Cross them, and we end up with barium. And because we need two of these chlorine-containing oxyanions, we put ClO4 in parentheses and then put a 2 after it. Now, we need to name it. First thing, is barium capable of forming multiple charges? And the answer to that question is no. Barium is a main group metal in group 2A, so it's not a transition metal or underneath the nonmetals, so we do not need a Roman numeral. So to name this, this is barium. No Roman numeral. Now we need to figure out what this is called. The most common chlorine containing oxyanion is ClO3 minus, which is chlorate. If you have one more oxygen, because now we have ClO4 minus, it's perchlorate. So this is barium perchlorate.